Hello everyone. This is Tumkur University, Department of Studies and Research in Organic Chemistry. We have done a presentation on reaction mechanism and synthetic uses of Beckmann rearrangement by the students of Organic Chemistry, 2nd MSc, 4th semester, Tumkur University, Tumakuru. The contents of our presentation include introduction, Beckmann rearrangement reaction, mechanism, applications, conclusion, and the reference. Coming to the introduction part, and this Beckmann rearrangement was discovered by a German chemist Ernst Otto Beckmann in the early 20th century. This reaction occurs under acidic condition. The Beckmann rearrangement is a method in organic chemistry that converts an ketoenzymes into an substituted amides. This rearrangement is significant in organic chemistry for its utility in the synthesis of lactams and isoquinones. Coming to the reaction of Beckmann rearrangement, it is an acid catalyzed conversion of ketoenzymes to secondary amide. Here, the ketoenzyme, which is under treatment of an acid catalyst, the reaction takes place to give an secondary amide, and this reaction is known as Beckmann rearrangement. Coming to the mechanism part, here in the ketoenzyme, the lone pair of electrons on the oxygen atom will going to attack towards an acid, and then the water molecule will be removed to form this compound, and then migration of an alkyl group will take place to form an carbocation, and then the removal of water molecule which has takes place in a previous step, and that water molecule will going to attack towards the carbocation, and then loss of H plus takes place, and then finally the product tautomerizes to give an secondary amide, and this is the mechanism of the Beckmann rearrangement, which includes the anti-group will migrating, the protonation of ketoxins and the removal of leaving group, migration of alkyl group attached to the carbonyl carbon, which results in the amino carbocation, and then the reaction takes place to give one secondary amide. Coming to the example part, so here the ketoenzyme, when it is treated with phenyl sulfonyl chloride, here the loss of HCl will takes place, and then the reaction takes place to give an secondary amide, and this is the very commonly used example in the Beckmann rearrangement. Synthesis of isoquinoline. Here, cinnamylaldehyde oxime, which is upon treatment with the phosphorus pentoxide, and this rearrangement will takes place to give an this intermediate, and then the loss of water molecule, that is the condensation reaction, takes place to give an isoquinoline, where the isoquinoline is a nitrogen containing heterocyclic compound which is fused with the benzene ring. And another most important applications of the Beckmann rearrangement will be the synthesis of lactams. Then acyclic ketones of all ring sizes undergo the Beckmann rearrangement of the oxygens to yield the lactams, a product considerable industrial importance used as a textile polymer and the nylon preparation. Here, the phenol, when it is treated with an hydrogen in the presence of nickel, hydrogenation will take place to give cyclohexanol. And then this, when upon treatment with a metal, that is copper, at 250 degrees centigrade, the reaction takes place to give cyclohexanone. And this upon treatment with an hydroxylamine, the reaction takes place to give the cyclohexanone oxide. When it is upon treatment with an acid in the thermal condition, the caprolactam will be formed, and this will be known as a lactam, that is the cyclic amide. And this upon treatment with the base in the thermal condition, the reaction takes place to give a pallone, which is a nylon preparation. It is used in the polymer, which is a long chain. This will be the most important applications of the Beckmann rearrangement. Conclusion. So here the Beckmann rearrangement involves the acid catalyzed reactions of an oxime to amides. Here acid will be used as an H2SO4, that is concentrated sulfuric acid. The reaction proceeds through the formation of carbocation intermediate. So, after the protonation of the hydroxyl group, followed by the migration of alkyl group to stabilize the carbocation, and finally the formation of ketoenzymes to N-substituted amide will be takes place. And this rearrangement is a classic example of a migration reaction where a group migrating one carbon to another. This transformation is important in organic chemistry for synthesizing oxime from isoquinoline and nylon preparation in the textile industry and for studying the carbocation stability and the rearrangement mechanisms. Reference: we have taken a reference from an organic reaction mechanisms fourth edition by V.K. Ahulwalia and Rakesh Kumar Parashar and organic reactions and their mechanism third edition by P.S. Kalsi. This is all about our present. Thank you.